So over the past several weeks, we've been talking a lot about quadratic functions. First of all, we've determined the a value, and that was the second change. We've talked about what the solutions are, what the vertex is. Remember, the solutions are the x-intercepts. That will be important for what we're about to do. And we've talked about writing functions in vertex form, factored form, and standard form. And we've talked about converting between the forms by multiplying or by factoring, which is what we just took a test on. Now, we are going to talk about actually solving a quadratic function. Remember that the solutions are the x-intercepts. So to solve the function, we need to find the x-intercepts. When we talk about quadratic functions and solving them, that's what we're talking about, is just finding the x-intercepts. Now remember, the x-intercepts happen when y is 0. So the solution to this function says here, the solution to a quadratic function happens when the function equals 0. So the first way that we're going to talk about solving a quadratic function is using the zero product property. That's learning target 9, is being able to solve a quadratic function using the zero product property, or the quadratic formula, or graphing it. In the next couple of videos, we'll talk about the quadratic formula and graphing it. For right now, we're just going to talk about the zero product property. The thing to remember about the zero product property is that anything times 0 equals 0. For example, 5 times 0 equals 0. Negative 3 times 0 equals 0. X times 0 equals 0. Or we could say, let's do 3x plus 4. If you times that by 0, it equals 0. Anything times 0 is going to equal 0. That's the whole basis of the zero product property. That's why it's called the zero product. Product is what you get when you multiply. So when you multiply something by 0, it's going to give you 0. So anything times 0 equals 0. And the solution to a quadratic function happens when the function equals 0. So when either factor of a quadratic function is 0, when it is in factored form, that means that the whole function equals 0. So if we look at this first example, the solutions happen when f of x equals 0. So when either x plus 3 or x minus 1 is 0, that means the whole function will be 0, and that's the solution. So what this is saying is any number that makes either factor 0 is a solution to this function, because that would make it equal 0, which is what the x-intercept is when the y is 0, when y is 0. So whatever I can plug into this one to make it equal 0, when this is 0, I multiply it by this, and the whole function is 0, which means that y is 0, so that's an x-intercept. Another solution happens when I figure out what I need to plug into this factor over here to make this factor equal 0. Because when this factor is 0, this times 0 would make the whole thing 0, so the whole thing is 0. And that's another x-intercept, or a solution. So if I can figure out what I need to plug into x to make this 0, then I get my first solution. So what do I need to plug into x plus 3 to make it equal 0? What does x have to be to make this 0? So I'm going to just subtract 3 from both sides, and I find out that x has to be negative 3. That means that when x is negative 3, this factor is 0, and then when I multiply it by this, the whole thing is 0, because 0 times anything is just 0, which means y is 0, so it's an x-intercept, or a solution. My other one comes when I figure out what x has to be over here to equal 0. So I just set this factor equal to 0, I add 1 to both sides, and x equals 1. So this tells me that when x is negative 3, this is going to equal 0, which means it's an x-intercept and the solution. And when x is 1, this will be 0, which means the whole thing is 0, which means that's another x-intercept. So if I were to graph this function, I know that it's going to cross the x-axis here at -3 and here at +1 because those are my two solutions. If I'm going to sketch this graph, I know that it's going to open up because a is a +1 and positive a's open up. So I can roughly sketch this as this quadratic function based on the solution. So I've effectively solved this function by finding the two solutions. Over here, the zero product property, remember, tells us that when either this factor is 0 or when this factor is 0, the whole thing is 0, so those are my solutions. So I'm going to figure out what do I have to plug in to this factor for x to make this factor equal 0. I'm going to subtract 4 from both sides. So 2x plus 4 equals 0. Subtract 4. So now I have 2x equals -4. Divide by 2. So x is -2. So that tells me that -2 is one of the solutions to this function. X equals -2. Now I'm going to figure out what I have to plug in over here to make this factor equal 0. What am I plugging in for x? So x minus 3 equals 0. Add 3 to both sides. X equals 3. So this tells me that when I plug -2 in for x, this factor ends up equaling 0, which means the whole thing equals 0, so it is an x-intercept. And when I plug 3 in for x, this factor ends up being 0, which means the whole thing is 0, which means that's my other solution, because whenever the whole thing, or y, equals 0, that's a solution. Over here, my first factor is just an x, so the thing I would plug in to make that 0 is, if I want x to equal 0, I already got my answer. Over here, x is 0, and over here, x plus 5 has to equal 0. So if I subtract 5 from both sides, x equals -5. So that tells me that in this quadratic function right here, using the zero product property, if x is 0 or if x is -5, the whole thing is going to end up being 0, which means that y is 0, which means it's an x-intercept and a solution to my quadratic function. So that's how we use the zero product property to find the solutions of quadratic functions. We just set each of the factors equal to 0, and then we solve to see what x needs to be to make each factor be 0. And whenever a factor is 0, that x value ends up being a solution. And that is the zero product property.